All right, so for today's class, we will be using the chat, and then if we have time, only if we have time, we play a game. All right, but today we actually have a full program because we have half the worksheet from last week before we continue to this week's worksheet. All right, so it's actually beneficial for you, which means that you will revise more topics for today for yourself. Okay, so without waiting, so if anything that anyone doesn't understand, you you still don't understand what I'm explaining, free to type into the chat. All right, so don't worry about giving me the wrong answer. All I want is for everybody to at least try. All right, so I have Clifton. I think whoever has just come in, can you tell me your name? Okay, I found your name. Welcome, Clifton. This is also your first lesson with me, Miss Ivy. Let me just put a tick. All right, so we have two people. Later, we might have two more new ones as well. Okay, let's see, is Clifton in already? Okay, welcome, Clifton, to Primary 5 class. My name is Miss Ivy. So if I'm going too fast or if you don't understand, feel free to type into the chat. Then if you need to go toilet or get a drink, don't need to ask for permission. Just type into the chat, I'm going to the toilet. All right, then when you come back, just type into the chat, I'm back. So we'll be using the chat. All right, only I can see your chat. You all don't see each other's chat. Okay, Skylar and Jervin, would you mind turning on your camera, please? Sibra's camera, there's some issues. So those of you who are turning on your camera, thank you so much. All right, today we really have a packed program. I really do not know whether we have time for a game, but we see how. All right, so we need to finish up last week's worksheet. Okay, so let me share today's slides. Okay, you can see the slide. So because we have new students today, so I want to just also run through the important slides on heat. All right. So, but we will run through very quickly. Okay. So we talk about better heat conductor, gain heat faster, lose heat faster. All right. So remember, the analogy is if you are a runner, if you're a better runner, imagine you're a better runner, you will run faster, right? So it's faster and faster. So gain heat faster and also lose heat faster. Okay. Then the opposite of that will be poorer heat conductor will gain heat slower and also loses heat slower. All right. So poorer is both words slower. Well, if it's better, both words are faster. All right. So next, heat always go from H to L. So we talk about HL milk. So heat always flow from a place of higher temperature. H stands for higher temperature to another place of lower temperature. All right. So we also talk about gain heat from, lose heat to. So please remember to use the word correct word here. Gain heat from, lose heat to. You must always tell me gain heat from who, lose heat to who. All right, then we talk about metal is a good heat conductor. And then anybody remember how are we going to remember the poor conductor of heat? What is a memory aid? Can y'all type into the chat? Those of you who joined me last week, what is a memory aid? Good job, Jia Ping. So the memory aid is POW. All right, so poor conductor of heat, you can remember it by POW. PAW, actually the animal's paw, paw. All right, plastic, air, wood. If I use the first letter, then it'll be the paw, the animal paw. Let me see, there's someone who just came in. Okay, let me admit Giselle. All right, then let me quickly mark her attendance before I forget. Okay, so take a quick look at this slide first before I go on. Okay, welcome Giselle. All right, so we continue on. So PAW will help you remember the poor heat conductor. All right, then we talk about this experiment. So all these are from last week, so I'm going very fast. So metal is a better heat conductor compared to plastic. So metal is a better heat conductor. You cannot write good, it's better to write better, comparing word, right? Better because you're comparing two things, two materials, metal material and plastic material. So ice, if I put a piece of ice on the metal plate, ice on the metal plate will melt faster. Ice on the plastic plate will melt slower. So ice gain heat faster from where? From the metal plate. All right. So to melt faster. So maybe in the word here should be plate. All right, metal plate. Okay. Right, so we also talk about there are two ways to write your sentences. Something gain heat from something else faster or slower, or fastest or slowest, depending on whether you're comparing two things or three or more things. If you compare two things, use ER. If you compare three or more things, use EST. So either you write gain heat from something faster, or you can write gain heat faster from something. So the gain heat from, you can break it. All right, so lose heat to, you can also write something loses heat to something, something loses heat faster to something. All right, so basically these four words, you choose one word. Okay, so these are the item. What material loses heat to what material? Right, so we continue with last week's worksheet. All right, so this is just a quick overview for those who have just joined us new today. All right, we actually went through these slides last 2 weeks. Okay, last week actually. All right, so here we have an ice cube, and then we have hot water at 90 degrees Celsius. So will the temperature of the water in the jar after 5 minutes, will this temperature of the water be higher than 90? All right, so underline the keywords. Will it be higher than 90, or will it be lower than 90, or will it be exactly same as 90 degrees Celsius? Can everybody type into the chat, please, quickly? 5 seconds. This is quite easy. Higher, same, or lower? Just choose. 5 seconds to type into the chat, especially for the newcomers who have just joined in, because this is the first time you're looking at this worksheet. This is last week's worksheet, which you will not have. Right, 5. Thank you, Siva. 4, 3, 2, 1. Thank you, Giselle and Kaden, Kaihan. All perfect answers. All lower. Right, so you have to explain the water lose heat to who. So most students, right, will just write me water loses heat, then full stop. All right, you write like that, you put full stop, is wrong. You must tell me lose heat to who. Lose heat to the ice cubes, as well as lose heat to the surroundings. So this is the surroundings, meaning the surrounding air. All right, surroundings, usually we have an air, so we are referring to the surrounding air, all the air around. Okay, so all these are surrounding air. So this hot water will lose heat to the surrounding air. The hot water also will lose heat to the ice cube. So if you are going to do the HL, like the brand of the milk, if you go NTUC, you can buy HL milk, right? So ice cube will be lower temperature. Hot water is higher temperature. Then the surrounding air also lower temperature. All right. So once you, H stands for higher temperature. Right. L stands for lower temperature. Okay. Temperature. All right. To save time, I just do the dash, meaning lower temperature instead of writing it 2 times. So then, can you all type into the chat? Heat always flow from H to L or L to H? Quickly, 5 seconds. Type into the chat. How does heat flow? H to L or L to H? 5, 4, 3, 2, 1. Thank you, Kaden, Siva, Giselle. Let me see who give me wrong answer. It's okay to give me wrong answer, but after today's lesson, no more wrong answer for this concept. Hi Han, heat must always flow like from a high place to a low place. Have you seen a waterfall flowing from lower to higher place? Waterfall doesn't go backwards one. Where?
In movie.
Yeah, in movies is
In movie can't go backwards. Movie can't go backwards.
Yeah, that one movies.
I also YouTube scene. You can
Okay.
just
Okay,
the video that it goes up.
Thank you for sharing, Kaden. But then we are talking about science. So H to L. So remember, H to L. All right, not L to H. All right, Marissa, take note. Also, heat always flow from higher temperature to lower temperature. Think of the waterfall. You know, waterfall always flow from a higher place to a lower place. The waterfall flow downwards, right? Okay. When you bathe, your water also flow downwards, right? Okay. So temperature always flow from H to L. That's why the brand of the milk, if you buy from NTUC supermarket, is called HL milk. It's not called LH milk. That is just a memory aid to help you memorize more easily. All right. So I will draw the 2 arrows. So it will be like that. This is the arrow shows the heat flow. So the heat will flow from H to L. Then the heat will also flow from H to L. All right. So the arrow shows you heat flow. So always when you do heat question, you must always look for H, higher temperature, look for L, lower temperature. So heat always flows from H to L, heat always flows from H to L. H stands for higher temperature, L stands for lower temperature. All right, so this is how heat will flow. So the hot water will lose heat to the ice cube. The hot water will lose heat to the surrounding air. So this is how you write your answer. Water lose heat or lost heat to the ice cube as well as lost heat to the surroundings. All right, or you can write surrounding air, also okay. All right, any question up to here? So this is the marking point. Which is a marking point. So you must tell them the temperature is lower than 90. Then explain. All right. Imagine here they ask you to explain. Explain why. Then you need to continue explaining. The water lose heat to the ice cube and the surroundings. All right. Any questions so far? So heat always flow from higher temperature to lower temperature. HL, remember the HL, the brand of the milk. All right, HL milk. Okay, so heat always flow from H to L. All right, next part. Might place for similar ice cube. Similar means size of the ice cube is the same. All right, cannot be one big cube, one small cube, not fair. Experiment becomes not fair. So for a fair experiment, all the ice cubes must be of the same size. So size of ice cube is the same. So maybe I write for you here. All right, similar can mean size of cubes. All right, size of the ice cube is the same. All right, for fair experiment. Okay, for a fair experiment or fair test. Right? So the jars also must be same size, but the jars are made of different materials. All right, so maybe this jar made of glass, maybe this jar made of plastic, maybe this jar made of wood, maybe this jar made of plastic, I don't know. All right, so 4 different materials for the jars. So he left the jars on the table. He recorded the time taken for ice to melt completely. How much time taken for the ice to melt and plotted it in a graph. You look at this bar chart. All right, so can you tell me which material, which jar, okay, which material, here is type of material, I got material K, L, M, N. Which material takes the longest for the ice to melt? Can everybody type in the chat, which material takes the longest time for ice to melt? Okay, well done, everyone. I don't see any wrong answer, so it's easy for everyone. So M, it takes the longest time. All right, let me write here, longest time for ice to melt, for the ice cube to melt. Then which one takes the shortest time? Which one takes the shortest time? Siva, okay, you're answering my second question. Okay, this one is the shortest time. All right, so material N will give the shortest time, okay, for ice to melt. Okay. Now they're asking you which material is most suitable to make an ice cream container. Now, if you want to make an ice cream container, obviously we don't want the ice cream to melt so fast, right? Otherwise, let's say you buy the ice cream from NTUC supermarket, then by the time you reach home, all the ice cream, solid ice cream become liquid ice cream. I don't think we enjoy eating liquid ice cream, so yucky. All right, so we prefer to eat ice cream in solid state. Yes.
I like liquid ice
okay, all right. So some of you like Hayden's
prefer the best thing.
Okay, all right, but most, Hayden, you have a very unique preference, but most people will like ice cream in solid state. Okay, so now I do not want the ice cream to melt so quickly. Now for such question, let Miss Ivy give you a tip, a tip. You always choose the answer is either the biggest or smallest, the extreme end. All right, so the answer is either biggest or smallest, or what I mean is the tallest or shortest. So in other words, your answer is either M or N. Please don't go and choose K and L. Even if you don't know anything, you cannot remember anything, you don't choose L and M. You either choose the shortest or you choose the longest. That means either you choose the smallest or the biggest. So the answer is one of them. It's either M or N. One of them is the correct answer. Don't go and choose L. Go and choose K. L and K are not the two extreme ends. L and K is not the tallest, it's not the shortest.